In today's video, we're going to go over the difference between simplifying, evaluating, and solving. Okay, I'm sure you've seen these three words before in math, especially algebra, and today I wanted to briefly touch upon the difference between the three of them. So simplifying. What is simplifying? Well, simplifying is not really looking for the answer to the unknown variables. Okay, we're not solving for the x here and we're not solving for the y. We are simply looking to try and to turn this expression into an expression with less terms. The original version has 3 terms. We're going to try and combine some so we have less. If you look carefully, 2 of these terms have the same variable. Anytime terms have the same identical variable, they are called like terms. In this case, the 5x and the 4x are like terms and they can be combined. In order to combine like terms, all you have to do is perform the operation in the middle. In this case, we are adding. So the 5x will be added with the 4x. To add, you gotta simply add the coefficient 5 with the 4, which will give us the 9. The variable x is simply brought down. Okay? The minus 6y does not have a like term, therefore you cannot really do anything with it except bring it down as well as is. Alright, now we can try and look for any further like terms, but as you can see, the 9x is not a like term with the 6y because the variables do not match, and this is the simplest form for this expression. Again, we're not looking for the actual value of x or the actual value of y. We are simply trying to simplify the original expression into something that's smaller with less terms. Now, for evaluating, you are given an expression usually, and you're also given the value of the variable. All you have to do in this case is use the value of the variable in the expression to figure out the total. Okay, so what we are doing here, we are simply substituting the x for the 8. Now to do this substitution, what we do is we simply are going to write down the 7, which is the coefficient. Now instead of putting x next to that 7, I'm going to use parentheses. And inside this parenthesis, I'm going to place the 8. What I did here is I substituted the x variable for its value, which is the 8. The minus 10 is the constant, and that simply is brought down. Now to fully evaluate this expression, in this case we're going to be multiplying first, and then we're going to subtract by the constant, which is the 10. So 7 times 8 will give us the 56, minus the 10, we're going to get 46. So I'll write it down here for you. Okay, so evaluating will normally give us a numerical answer in the end. Once you place the variable, you perform the operations, you're going to get an answer. Now for solving, we do not know the value of the variable, but we want to find out. That's why it's called solving. We're finding out what that x is. Now I'm going to go into further detail later on how to solve linear equations, but for now I'm going to quickly show you this just so that you can see the difference between simplifying, evaluating, and solving. Now for solving, as I said before, we need to figure out the x value. So what is x truly equal to? Okay, and we can find out by separating everything away from the x, leaving the x all alone. So what I'm saying is we got to remove the minus 15 and the 8 away from the x until nothing is left on the x's side of the equation. So you can think of the equation as 2 expressions on 2 different sides. In this case, you have the expression 8x minus 15 equal to another numerical expression, in this case the 9. We want to transfer everything from the x's side to where the 9 is, leaving the x alone here. So the first thing we're going to do is we're going to try and remove that constant. Now the reason why you want to start with a constant in this case is because there is a constant on the other side, which means the 15 will be able to combine with a 9 if you transfer it to the other side. Now we can just simply move it over to the other side because that would not maintain the value the true value of x. So I can just move the minus 15 over here. What you can do though is you can eliminate it from this side, transferring its opposite value to the other side. And here's why you're allowed to do that. Well, one way of eliminating a constant is by writing its opposite value underneath it. Since you are subtracting by 15, you're going to be adding by 15 underneath it. Okay, so you're adding 15 to both sides. Now the reason why we're adding 15 to both sides is because we want to keep this equation balanced. Whatever you do to one side, you do it to the other side, so the equation remains equal on both sides. What this accomplishes now is the minus 15 will cancel out with the plus 15 because they're opposites. Think of it as 15, take away 15, giving you 0. We're simply going to cross them out. Now over here, I'm going to bring down the equal sign. I use that line to show the two different sides, but also to show you where the equal sign should come down, which is there. Now here we're going to add the 9 with the 15, giving us the 24. On this side, the 15 is cancelled, leaving you with only 8x, which is going to be brought down next to the equal sign. Alright, we're one step closer to figuring out what the actual value of x is. Now the last thing we have to eliminate here is the coefficient, this 8. And in order to eliminate it, we have to do the opposite operation. Just like we did the opposite operation with the subtraction here by adding. In here, the coefficient, the 8, is multiplying the x. So we got to do the opposite operation. What is the opposite operation of multiplication? The answer is division. So because the 8 is multiplying the x, below it I'm going to divide by 8. Whatever I do to this side of the equation, I have to do it to the other side so the equation remains equal on both sides. Now what the 8x divided by 8 does is the 8's will turn into a whole, or 1. So I can simply cross them out and put a 1 underneath it and bring down the x. Now the x was not touched because the 8, the denominator 8, canceled the coefficient 8, giving you a whole, x not changing, equal, and on this side we do 24 divided by 8, which gives us the 3. Now let's think about it. What is 1x really? Well, that is 1 times x. And 1 times x, or 1 times anything, is the same thing. So 1 times x could be simply said as x, because the 1 does not change any values when you multiply by it. So therefore, if 1 times x is equal to 3, x will also be equal to 3. So this is the value of the variable for this equation. We just solved this equation for the value of x. Okay, so in a quick recap, simplifying, you're not looking for the value of the variables. You're simply combining like terms so that you have less terms to deal with. Okay, this could be one of many steps in order to solve more complex equations. Some equations will have many terms, and sometimes you're going to have to simplify them by combining the like terms in order to make the equations easier to be solved. So simplifying is simply a procedure to later on get to solving a more complex equation. Evaluating, it's used to check or to figure out the total of an answer. Okay? At a later video, I'm going to show you more in depth on how to solve linear equations and also how you can check that this answer is correct by using the evaluation method, where you simply take the value of x, you place it into the equation again, and you check if the equation is truly equal. Okay? But right now, I'm simply showing you the 3. Now I'm going to show you 2 more things before we conclude this video, and that is expanding versus factoring expressions. Okay? Now these are a little bit less common, especially in between 6th to 8th grade. You're going to see a little bit more of that when you go later on in high school, especially factoring quadratic equations and quadratic expressions. But right now, we are only dealing with linear expressions. Now, what are linear expressions really quickly? Linear expressions are any expressions without any exponents next to the variables. they don't have an exponent. In this case, you simply have the x without an exponent on top. So these two are linear expressions. Now let's focus on expanding first. In order to expand, what we have to do is we have to multiply the number outside the parentheses with both terms inside the parentheses. Okay, this method actually has a name. This is called the distributive property. We are distributing the 5 by multiplying it with the 3x first, and then we're going to multiply it with the 8. So this 5 will multiply the 3x, so 5 times 3x, and then I'm going to bring down the plus, and now the 5 multiplies the 8. Okay? Alright, so the 5 got distributed to the 3x with the 3x as well as with the 8. Now, to multiply a number with an algebraic term, all you got to do is multiply the number with the coefficient. So in this case, 5 times 3. 5 times 3 will give us 15. And the x simply comes down. Okay? That is what you need to do. Now, to multiply a number with a constant, well, they're two regular numbers, so you just simply multiply them together. 5 times 8 giving you the 40. The addition sign simply will be moved down. Now, this gets a little bit more complicated once we introduce negative integers as well as subtraction. But for now, I'm simply showing you what expanding is and the distributive property. Now, factoring is actually the exact opposite of expanding. Factoring starts with an expression that kind of looks like that, and you're doing the reverse to get to an expression that looks like this. So what we're doing when we're factoring is we're splitting the expression apart. All right? Now, the way that works is by finding the common factor between the 12x and the 24. Now, I need to be a little bit more specific. It's not just the common factor between 12x and 24, because 12 and 24 have a lot of common factors. You want to find the greatest common factor between 12 and 24. So to help us do this really quickly here, I'm going to briefly write the 12 and the 24 side by side so we can think of some numbers that can go into both. Well, 2 can go into both 12 and 24. Also, 4 can go into both. But at the same time, so does 3 and 6. All right. Now, if we think a little bit longer, you'll find out that 6 is actually the greatest common factor that goes both into 12 and 24. 6 times 2 gives you the 12, and 6 times 4 gives you the 24. So when we split this expression with the parentheses, the number that goes outside of the parentheses will be the greatest common factor. In this case, the 6. All right? Leaving us inside with two slightly different terms. And here's how you do the remaining terms. Okay, so inside what will happen is you're going to write the factor that you need to multiply the 6 with to get back the 12x. Let me rephrase it so it's a little easier to understand. 6 times what number will give me the 12? Well, we kind of already did it here. So it's 6 times 2 will give us back the 12. However, the 12 has an x variable next to it, so this 2 needs an x next to it because the 6 does not have an x. So you need the x to come back. Now that 6 times 2 gives us the 12, and since the 2 has the x next to it, you're going to get 12x. Now we bring down the plus, and we ask ourselves the same question. 6 times what number will give us the 24? Luckily, we also did that here. It's going to be 6 times 4. So the 4 goes over here. Okay? 6 times 4 gives us 24. Now, before we conclude, we can do a little test to see if this expression was factored properly. The way you do that is actually by performing the distributive property. expanding the expression to see if you get back the original. So underneath it, I'm going to do that really quickly for you. First, we're going to do 6 times 2x, 6 times 2x, all right? And then we're going to do 6 times the 4. So going to bring down the plus here, and then 6 times the 4. Very similar to what we did over here. The 6 times 2x will give us the 12x. Bring down the addition. And then 6 times 4 will give us the 24. And this is the expression we got from our factored expression. Is it the same as the original? Yes, it is. So we can conclude here that we factored this correctly. Now, when will you need expanding and factoring? Well, factoring will come more into play when you start doing Algebra 1, which we're going to cover at a later topic. But the expanding is used very often to solve linear equations because it gets rid of the parentheses. This is one way to eliminate any parentheses in any equation, by distributing the number outside of the parentheses with what's inside of the parentheses. Okay? So, in a recap, what did we learn about today? Well, we learned about the difference between simplifying, evaluating, and solving. Simplifying, you're simply combining the like terms so that you can reduce the number of terms. Evaluating, you are given the value of the variable, you're substituting it into an expression that was given, figuring out the total of that expression. You're evaluating the expression. Solving, we did not know the value of the variable, you had to find out. And we did the balancing method in this case in order to eliminate everything around the x term, so the x is left all alone here, giving us the answer. Alright, if you guys enjoyed this video, please make sure to like as well as subscribe. Also, please make sure to write any comments with any suggestions or recommendations for the future video. Thank you so much and have a good day.